Okay, very good. So what we were doing last time, do you remember? We were doing this, and let me just recall the question at which we left. That we have these two intersecting circles,
Moving
right?
the question number 11.
I'm sorry, I could not hear you. Sorry, Betty. Let me see you.
Proving the question number 11.
Yes, they are very good, very good. So were you able to do that question or no?
No.
No, okay, no problem. So I'm going to do that question. So we have two intersecting circles, right? Okay. So what happens
Yes.
there is this. Oh, one moment. Okay. So let me just make it like this. Sorry. Okay. So here is what? Here is a chord, right? That, like this portion, it is a chord of the right here. This is a common chord of the circle, right? And what we are doing is that we are going to draw tangent lines from a from a point T on here, okay? And then, so I have drawn a tangent here, okay? And then I'm going to draw a tangent here. All right, beta? Okay. So what we have then is this, say this point is P and this point is Q, that is P and Q are the points of contacts. All right, okay. So then,
Yes.
very good, thank you. So we have to prove that TP and TQ are congruent, correct?
Yes.
Okay. So, so what I was trying to do is this, that I was trying to make a, we did a lot of things, and then we ran out of time. So first, let me do this here. Let me create let me recall a theorem for you. And a theorem means a statement or whatever. Okay. And then what we will do is we'll prove it afterwards, because the question that you gave me from your textbook, that is the question that we are doing, that was not a question in the CBSE examination. Okay, in the CBSE, the question that they had asked was part of this that I'm doing. Okay, all right.
Yes.
Thank you. Okay, so see, the property goes like this. Let's say I have a circle and I have a point. Uh, come on. And I have a point T here. Okay, got it? So if I do this, if I draw a tangent to this circle from this point, okay? So what happens is the tangent, say, meets the circle at the point P, all right? So, and then I draw a secant line here, okay? And say the secant line meets the circle at the points A, uh, just a moment, beta. Here we go. So the circle A and B. Okay. So this is called power property. That is for this tangent. That's what I think it is called. So that will mean TP square is going to be TA times TB. This theorem is given in your book. All right. Makes sense? Do you see that?
Yes.
Okay, very good.
Yes.
Yeah, very nice. So now tell me this here. I have, let me call this point A and this point B. Okay, am I clear? So,
Yes.
so if you look at these two circles, okay, then who is TP? The length is square. Yeah, just apply this theorem from here. Okay, can you please?
Yeah. Yeah.
Yeah, so what that will be, look at the picture. See, just like this, if this is the length of the tangent,
TA square.
not TA square, TP square, right? That's what we have here. Okay, notice that it was TP square. T to the distance of the point of contact, right, or the point of tangency, is square of that, right, beta?
Yes.
Okay, so TP square equals how much? See this here? What does it say here? It meets in A and meets in B, right? Okay, so that equals TA times TB. Do you agree?
Yeah.
Okay, very good. So this is TA times TB, correct? Okay. Now what we have is that and what do we have to prove? We have to prove this, right? Am I clear?
Yes.
Right? So tell me, who is TQ square by the same property? Who is TQ square? Yeah, who is that?
T TP into TA.
TB into TA, very good, or TA times TB, right? Are we good? Which is the same thing as what you said. So this is TP. So what does it mean? See, this and this are the same, right? So these two quantities will be the same, won't they be, right? Am I
Yes.
clear? So their non-negative square roots will also be the same. Do you understand what I said? Okay.
Yes.
So very good. So if I take the non-negative square, so do you think this is done? Do you think so?
Yes.
Okay.
Yes.
So would you do me a favor, please? Just write it as a logical sequence of sentence, okay? And
Yes.
then I mean a proof with like in a logical sequence, and then just send it to me, okay? And you said that you will send that question that we did last time later, right?
Yes. After the meeting.
After the meeting, chair, yes, you don't have to stay awake the whole night. All right, yes, just whenever you get a chance. Okay. So any other question before I take up the next question? Any other question that you have for me? Mm-hmm. I didn't hear what you said. Abita?
What?
I said any other question that you have? Do you have any other question?
Yes.
Okay, go ahead. Tell me which question. Yeah, that's what I'm asking. Okay, beta?
It's 12.
12. Okay, very good. So we'll go over 12. Now, before we go over 12, how about this? Would you like this? Because see, we used this property. Okay. And as I said, when we talked about the Cbse examination, okay, then the proof of this property was on the test. This was not on the test, okay? All right. So can we do this? Can we take up this property before we take up 12? Or let me take up 12 first. That's okay. We'll keep this property for a discussion at the end. You have a question. So can I erase it? Can I mita de isko?
Yes. You can erase it.
I can erase it. Very good. Thank you. Thank you. So just give me a moment. Let me look for the question that you are asking. Where did you? So let me just look for the book first. Okay. So one moment, please. Just one moment. Okay. The question number 11. Okay. Let's go for it. 11. Okay. Right, yes, I'm almost there. And which page is that question on again? 8 point somewhere, right? 8 point. Yeah, just write in the chat. I would know then, okay? 8 point. Yes, I got it. Don't worry about it. Okay, beta? I got it. So, question number 10. Oh, this was the question that we did. This was the question number 11, what we just did. Okay, beta? So,
Yeah, we just proved TQ is equal to TR.
oh, that is the question number 12. That's what you said. I'm sorry. Old people have hard, problem in hearing, right? Okay. So what the question is this, that I got a circle, right? Okay.
Yeah.
And then this is another circle. Okay. So they have a common point of tangency. All right. And here is a point, what? P. Okay. And what they are asking us to do is this, that here I'm drawing a tangent here, right? And I'm drawing a tangent here. All right. So they are calling this Q, right? And they're calling it what? R. Okay. And they want us to prove that, oh, sorry, this is T. Okay. So they are asking us to show that TQ, this equals how much? PR. Am I correct?
Yes.
Okay. So we have this, that is, so we got all this, right? So tell me, how would I do that? I have to show this, right? Okay.
Yeah.
So yeah, think about it. Think about it for a minute until I make, and I'm going to erase this. Is that okay? Is that okay, beta? Oh, I could not hear you.
Yes, you can erase it.
I can erase. Yeah, and I have your full attention, right? Because I cannot see you. So all right.
As there is a problem in my camera.
Oh, and you, no, don't worry about the camera. No, I don't want you to be seen
I'm
here because,
extremely sorry for
yeah,
that.
yeah, don't worry about the camera. We don't have to turn the camera on. Okay. So tell me this here. If I have just one circle, all right, and say I have a point T here, okay, all right, and I do this. I draw these tangents to the circle. So can you tell me what property do these satisfy? Say this is Q and this is R. Yeah, what property do they satisfy? Can you tell me, please?
TR is equal to TQ.
Very good. TQ equals TR or TR equals TQ. Either way, it's okay, right? Okay, so
Yeah.
let's go to the next part now, okay? That is here, I have to show TR equals TQ, but they are touching different circles, aren't they, right? Okay, so can you please tell me something that I should do here in order to match them properly? Mhm. See this here? Because a problem is this, that they look congruent or equal, in other words, right? But they're on different circles, right? But the circles have a point of contact. So what can we do here? Tell me. Yeah. Did you understand my question?
Can you explain it again?
Yeah, I'll say that again. Yes. The question is this, that I have to show this, right? And this one you knew already. Okay. But the problem
Yes.
was that this is just one circle, right?
Yes.
Okay. And these are two different circles, right? Different radii
Yes.
and everything. The only thing we have is that they have a just one point of intersection, or they touch each other informally, right? Okay. So
We
what
can draw the line from T from the bottom of the circle.
to the common point on the circle you meant, right?
Yes.
Beautiful. Very good. Very good. Very good. So let's call this point P, right? Am I clear?
Yes. Yes.
So tell me this here. What I have? We have this point T, and we sketched tangent lines R, right? So just tell me, how would you connect now TQ and TR? How would you? See?
T.
T, Q.
T
Uh-huh.
TP is equal to TR and TQ is equal to TP.
Very good. TR. And this is also, sorry, equal to TP, right? So these two will have to be equal, right? Make sense?
Yes.
So what we have to do now is we have to write it logically, all right, and send it over to me, okay? All right.
Yes. Yes.
So did you want to prove that property, that power property that we talked about? Because that will involve lots of steps. And as I said, part of that was on the examination. So they may take a different part and put that on the examination, right? Okay.
Yes.
Okay.
Mm.
So I can erase it now, right?
Yes.
And I will post this recording, all right, so that you can easily watch it, all right?
Yes.
And I'll just post it on the YouTube, so nobody can say can see who you are, and all, in case they want to see somebody, they will see only Buddhe Bhupaji. Okay, all right, okay. All right.
Yes.
So, so here, so what was the property that we talked about? Let me recall it for you. Okay. The property that we were talking about was this, that say I have a point T here, right? And I go ahead and draw a tangent from that point, right? Are we clear? Okay.
Yes.
And then I make a secant line. You know what a secant line is, right?
Yes.
Okay, very good. Yeah, I know you know what a secant line is. So say this point, the point of contact here, or the point of tangency is P, and let's say these points are A and B. Do you remember which property are we trying to prove? If you don't, no big deal. Do you remember what are we trying to prove here? It's okay if you forgot. Just tell me you forgot, or you can write in the chat. Mhm.
TP plus A plus AB.
Very good. TP square equals TA times TB. And I'm not going to write it like this again and again. In our discussion, it will be understood that when we are writing it, it would be just just the distance between the two. That's what we want to prove, right? Okay. And
Yes.
I don't know, this doesn't look that intuitive. So fortunately, we know, or we have been given what to prove, right, Beta? Okay. What I would do is So think of, let me just tell you this step. That's what I would do. Okay. I mean, if I have a circle, I will talk about the circle center, right? Say, so the center is how much? Say, the center is not how much. Then, okay, so looks like that our connection disap disappeared. Okay, so I'll wait for you to connect and let me start the recording in the meantime. So now you are back. So I'm going to start it. Okay. So again, what we are trying to do is that can you hear me? Just write in the chat. Just don't use the microphone. So that will just write in the chat. Okay, Betty? Because the yeah, just put that in the chat so that way we will have less load on the connection. Okay. All right.
Yes.
So, okay, so I can hear you very well. So good. So that's what we have to show, right? And how did we want to proceed? We wanted to proceed like this, that we will, as I said, let's look at the center, okay? Because I have to, see, connect TA with TB, right? And I'm just, in a way, I'm doing kind of acting. That is, I'm just trying to show you how to think about this proof. Okay, beta? All right, so very good. So let me do this here. Go ahead and erase it. Come on. Okay, very good. So if we look at it, what we got, so we are going to use this O in order to connect them all together. All right. So am I making sense? Just do this show gesture.
Yes.
Yeah, if I don't make, yeah, if I'm making sense, just show me a thumbs up. If I'm not, then just show me, what would you show? In the emoji, there is something like this, okay? Show me that, so I'll know that I did not make any sense, okay? Good, yeah. So, so I'm making you said yes. So what I'm going to do in that part is this, that I shall connect this, because we have to connect those guys together, right? Okay, in order to talk about these. So I'm going to connect them all. Okay. And my picture is not perfect because when you're drawing a picture by hand, that wouldn't be perfect as well, right? So notice this. Let's let the radius of the circle be, I'm saying the radius, right? So let's let the radius of the circle be r. All right. Okay. So if the radius of the circle is r, how much is this distance? Can you tell me, please? How much is this distance? Mm-hmm. Oh, I didn't see. Oh, we got disconnected again. So let me stop the recording and wait for you to come back. See, the radius of the circle is how much? Isn't it r, right?
Yes. OP is equal to OB.
OP, oh yeah, OP of course is equal to OB. Very good. And they are all, and this is equal to OA. Very good.
O.
Right?
Yeah. OA.
Very good. So we have all these equal to R, right? So we have to connect these. And while trying to connect these, let me just make another connection, whatever connection I can think of. Sorry. So another connection that I'm making is this connection. That is, I'm connecting this thing here. Okay, these two here. All right. And what we have to do is that we have to arrive at this thing. All right. Did you read that proof anywhere, this proof anywhere before, or you did not? Say yes or no. Did you read this proof or you did not? The proof. I think it's in your book. I think so.
Yes.
So
In the
you
hint.
okay. So let's and you may not remember. So let's just go in that style and see how much we match with the proof that you have in the book. Okay, so anyway, so this is the purple distance, right? Can you tell me what this angle is? What is this angle? 90 degrees. Very nice, beautiful. So this angle is 90 degrees, right? So if this is 90 degrees, then we can look at the right triangle. Excuse me, Betty. Okay, right triangle. I'm trying to align them together. Okay, so P, O, T. This is the hypotenuse. Are you okay with me just, changing the posture of the triangle? Are you okay with that? Is that clear? That I just brought this triangle here. I asked you a question, beta. You're muted, so I cannot hear you. Okay, so we disappeared again. So I'm going to again stop recording because we lost connection. So I have started recording because you can hear me. So what I was asking you was this, that are you okay that this triangle is the same as this triangle, this with this purple hypotenuse? Is this clear, Betty?
Yes.
Okay, very good. So how much is this if they are the same? Yeah, look at the picture on this side and tell me how much is this distance here, this one. Uh-huh. Tell
OP is R.
R, very good. OP is R. And there is very fortunate thing, and the fortunate thing is this, that we have to talk about TP, and TP has showed up here. See that here, right?
Yes. Yes.
So by Pythagorean theorem, what will happen? OT square will become how much? Yeah, tell me, please. OT square becomes, yes, these are the legs of that right triangle, right? So what does Pythagoras tell us? OT square is,
OP square plus
very good, plus,
PT square.
beautiful, plus PT square. So that's what the OT square is, right? Very nice. Now I have to do this, that is, I have to somehow connect these with TA and TB, okay? And our time is like, yeah, I have to go on to another thing, so I'll be a little quick now, all right? So what I'm going to do is this, that I am going to draw a perpendicular line here. Is that clear? Okay. So
Yes.
all right. And let me call the foot of this perpendicular on the line as N. We call it N anyways, right? Are we good? Make sense? Okay. Now, look at this. Do you see TB anywhere in here? TB. See?
Yes.
Very good.
Longest.
Very nice. So let me just color TB slightly differently. Okay, very nice. So this is TB, right? Are we good? Good.
Yes.
Now, see this here? We have TB and then we also have TA, right? Don't we? Notice that? Okay. And then what we will have is this. Let's see this here. That is, I have this here, right? These are perpendicular lines, right? And here, these are congruent, right? Am I making sense? Right? And this line is common. Okay, all right. It would take you just not too much to show that, oh, you won't have to show much anyways. See, this is isosceles. Say yes or no. This triangle which I'm doing, O A
Yes.
B is isosceles. All right, are we clear? So what will happen?
Yes.
These are congruent, these are congruent, so everything will be congruent. So what happens now? Bn equals how much? Yeah, tell me please. How much is Bn? Does Bn equal?
B and
Equals, this is
and
Bn, Na or A, yeah, Na or An. And let me do this. Let me go back to our no. Very good. I'm so encouraged in spite of poor, connections that we had. So the reason I brought those over is this, that we already have TB here. The TB is the blue line, right? Makes sense?
yes.
But we don't, TA is only part of it, but that should not be a problem. Because why that should not be a problem? Because let me choose a color here quickly. All right. So say if I want to write my TA, okay, then what will happen? TA is going to be NT minus NA. Say yes or no.
Yes.
That makes it right. Very good. And looks like we might be able to wrap it all together. Okay. All right. So we are not done yet. Okay. But I have to go, so I have to go. Okay, beta. We had so many connection interruptions. So what I'm going to do is this, that I'm going to finish this proof for you. Okay, beta. All right. And let's meet at the same time tomorrow. Would that work for you? So we are going to, I'm going to finish it for you, because we are almost done anyways. So you noticed this portion here, right? Uh, Before we left. So what I'm going to do is, remember we had obtained this OT. Now there is another way to obtain OT, because we are getting NT minus NA here. So we can connect this NT with OT. If we look at this right angle triangle, see, I'm making it in green, which is barely visible. So that green triangle is who? That's light green, not very good. So let me just change this here to dark green. Where is the, yes. Okay. So the green triangle is, we have O, we have N, and we have T, right? Okay. So we will have how much? Another relationship. The other relationship we have is here. This is the right angle triangle. So OT is square equals the sum of the squares of these two sides. So which will be what? ON is square plus N T squared, right? So that's what we get. All right. And now what we have is this. So when we got this, we have this green equation and this black equation. So I'm just going to write those two down here, because that was just in passing. All right. So I'm writing the green equation and the black equation. So what do we notice by the black equation? That OT square is how much? OT square is this quantity, right? And from the green equation, what do I notice? That OT square equals this quantity, right? So remember this, we have to talk about TP square or PT square. So what you get here is this, PT is square plus r square equals how much? That equals on square plus nt square, because that's another format of the value of ot square, right? Okay, so we got all these. Now we have on square, and we have to relate it with something that we know. So how about this? See this here, we have this right triangle here, okay? And I'm talking about this right triangle, which is NOB, right? Okay, so OB is how much? That's the radius of the circle. And we have ON that we want, that, that's what we want to discuss. And then we have BN. BN is a portion in this line that we are trying to discuss. So what does this give us? This gives us this, that OB square equals how much? OB square equals BN square plus ON square, right? So here we got our ON square. So ON square is what? Then OB square minus BN square. And who is OB? OB is simply R, so that is R square minus BN square. Okay, so what we got is, we got this ON square equals R square minus BN square. So we got PT square plus R square equals R square minus BN square plus NT square. Okay, so this is, we got this far. So now what I will do is, let me see where to make a space. Uh, I'm going to erase this now because we have gotten all this here. So I'm going to make a space here. Okay, so come on. Okay. And before we go there, what happens here is this. Notice this. These R squares will cancel, right? So we got this. We're getting there. PT square, TP square would be the same. And then we have how much? This portion, which is NT square minus NB square, right? So we have PT square, and now we have to do it algebraically. I mean, I wanted to do things geometrically as much as possible, but let's just take help of this now because getting late for me too. All right. So these are difference of two squares. So I'm going to write it like this. Uh, I'm going to write it as Tn, if you don't mind, minus Nb. NB mean just the lengths. Okay. And then Nt, or again rather Tn, okay, Tn plus Nb. Okay, so what do we get here? Pt square equals, now if you look at Tn minus Nb, or Nb is this one, right? But Nb and Na are the same. You can easily see that because this is, this triangle and this triangle, they are congruent. So they are the same. So what we can write is this here, that this is Tn minus Na. Why did I have to do that? Because I wanted Ta, right? And here it was relating it to who? Bn, right? Okay, so we have Tn minus Na here, and because they are congruent, and then we got Tn plus Nb. So what we get is this. Pt square is, how much is Tn. Tn is this, and then I'm just messing up the picture again. And Na is that, so that will simply be how much? Ta, right, in length. Okay. All right. Let me just put that like this here. And then if I add Tn with Nb, that will be Tb. I'm just putting these here just for sake of lengths. I don't have to put it here because I already have a square. So this is what we proved, and this was, and portion of this was what was asked in your examination. Okay, so that's why we wanted to do this proof, and we started with the in the beginning with an application of this theorem, which states this. And as I said, that you can call it the power property of tangent. I think that's what it is called in general.